Okay, it's time to switch from a plain split holdout approach to cross-validation. So I'm going back to this bike buyers data set, so you may want to go and find yours. And I have this side-by-side pipeline where I've got a regression algorithm over on the left-hand branch and a classification algorithm on the right-hand branch. Now, normally you would just have one modeling branch in your pipeline, but this is a good way to just do a side-by-side comparison for illustration purposes. All right, so I've taken the liberty of running this. And if we take the regression one here, boosted decision tree, let's evaluate the model. And we see we have an R squared of 20.243, RMSE 0.4464, MAE 0.364. So I've been kind of eyeballing these and trying to keep track mentally, but it's better to go ahead and actually track these. So let's just say we're going to go boosted decision tree. I've got a little spreadsheet over here. R squared was that number there. RMSE. And MAE. All right, so this is our 75-25 split technique. Let's take the metrics from the two-class neural network. And I've got an AUC of 0.658. And F1 of 0.591. And accuracy of 0.612. Now you'll note that this F1 and accuracy score are at the 0.5 threshold, so you might want to have in mind what your expected threshold or distribution is going to be, and you can slide that to recalculate your accuracy score and F1 score accordingly. So if I were to slide it down, then my accuracy goes down, my F1 changes a little bit. So it's important to understand that and get a feel for what your priors might be with regard to your distribution. We'll get into that as we get into putting a little financial evaluation to your model in upcoming sessions. All right. So now what I'd like to do is let's switch from split holdout. So I'm going to get rid of my split data and my trained model. And I'm going to bring in another set of pills. So I'll do partition and sample. Now you may recall using this one in the past just to create a sample. In this case, we're going to actually use it to do some cross-validation. So I'll go ahead and configure it. Instead of sampling, I'm going to assign various partitions to folds without replacement. I'll make it a randomized split. Enter my random seed. You'll enter yours. We want to partition evenly so you can actually do different proportions. And then it defaults to 5 in Azure Machine Learning. We want to change that to 10 and do 10 partitions. 10 cross-validation folds is the standard best practices today, especially if you've got a fair amount of data. All right. And then we won't stratify the split. Okay, so this is partition and sample numeric or partition, actually, numeric label data. All right, so now I can copy that and move it over to the other side. And this is going to be the same thing, except I am going to partition categorical label data. All right, so let's see, we're partitioning and sampling, we're creating 10 folds. We still have our algorithms floating out there. So let's come back to our components. And this time we're going to run a cross-validation. All right, so cross-validate model. And cross-validate actually trains and scores your model. So we can actually get rid of the score model as well. And we can bring our evaluate models up a little bit. So for the partition and sample, I'll bring that into my dataset side. The untrained model comes in here. And my scored result, well, actually I've got evaluation results by fold, but let's go ahead and bring the scored result into the evaluate model. And one of the things that cross-validate needs is, what is my label column going to be? All right, so we can go to bike buyers numeric tabular, preview the data. And see that on the numeric side, it's purchase bike numeric. So I can go back and enter that. And that's all we need to do. We're pretty much ready to go at this point in time. I'm going to edit the node. So cross-validate numeric model. All right, copy and paste. Set up the cross-validate on the other side. And in this case, this will be cross-validate my categorical model. Okay. That's really all there is to cross-validation. Let's run it now and see what we get. All right, the job has been submitted. We'll pause the video and come back when it's done. And I ran into an error. I'm pretty sure I know what that one is. We can just go back to our cross-validate model. I forgot to update the column name when I copied the pill over. So instead of purchase bike numeric, we are going to do purchased bike. That's our categorical variable. And we will resubmit and run it again. So I'll pause again and we'll come back when it's done. All right, our cross-validation is done running. So we will first take a look at the cross-validate model and let's see what we've got. We've got our scored results, which we would have gotten from the score model pill using the split holdout approach. And we've got another one called evaluation results by fold. So let's take a look at both of those real fast. So the scored results we can see mirrors what we've had before. Our scored label 0.745 indicates that we're likely to consider this a purchase bike. 0.411, maybe not, even though in this case they actually did purchase the bike. Here's one where the scored label is 0 and we have a low, or is 0.12 and we have a no purchase bike. And then you can also see which fold number each particular data point was assigned to. All right, 0 through 9 for 10 folds. So that brings us to the next one, evaluate results by fold. We can see we have 100 examples in each fold. So this is a pretty small data set, 1,000 rows. So we only have 100 per fold. And here we can see our MAE, our MSE, our R squared. And we can see that the R squared has a good bit of variability in it, with a mean of 0.16, but going all the way from 0.26 something all the way down to 0.015. So that's just product of the small data set that we have, and the fact that we're only using 100 instances per fold. So most of the data sets you'll be working with for projects will be much bigger than this, so you'll see probably a little bit less variation from fold to fold. So here we can see the mean and the standard deviation from fold to fold, okay? So that brings us to our next evaluation metric, which is the evaluate model. So we preview the data, take a look here, and we can see our overall R squared is 0.182363, so I'll copy that. And go into my Excel spreadsheet. So this is X validation. R squared is that. RMSE is that. And then we have MAE of 0.361405. So this is pretty common for cross-validation. You're going to get a slightly lower R squared, but it should be reasonably comparable. And you can see we get more or less the same effect with our MSE and MAE. That's due to the fact that we're using all the data and we're creating multiple models and averaging them out rather than just taking one single run. So depending on your split holdout values, you may find it is a slightly different, maybe a little lower most of the time. Occasionally, you might find the scores a little bit better. All right, but this is a little bit more representative of how your model will generalize to a population using cross-validation. All right, so let's go back and take a look at our neural network two-class classification. And we'll get the same type of thing. We'll take a look at our scored results. We will take a look at our evaluation results by fold. So here for the scored results, we can see our true false. We have a probability that has been assigned, also the fold number. And of course that fold number histogram is straight across because we had 100 in each fold. All right, so how did we do? Purchase bike, true, true. Okay, there's one where it was a false. True, false, true, true, false, false. All right, so now we can see how we did by fold. So here we have our 10 folds again, and you can see the AUC for each fold. You can see the accuracy for each fold. You can see the F1 for each fold. And you've got your true negatives, false negatives, and so forth. You can actually build your own confusion matrix for each fold as well. All right. So here we have an AUC of 0.693 with that standard deviation, an F1 score, which is sort of a one measure score that includes both precision and recall. 0.608 is the mean. Accuracy 0.638. So a little bit better than a coin toss, and that might be worthwhile. All right, so let's take a look at our other results. Evaluate model. And here we get our rock curve, our AUC of 0.689. F1 at our 0.5 threshold. And accuracy of 0.638. All right, so our AUC actually went up. So did our F1 and accuracy score using cross-validation in the two-class neural. All right, so that is cross-validation. I did take the liberty of adding the random seed to my cross-validates when I forgot to change the label value the first time around. So you want to make sure you do that as well. And that's all we do, cross-validate. You replace your split, you replace your trained model with the cross-validate and partition and sample. You also remove the score model, and that's about it. So cross-validation gives you a little bit better representation of what your model will do when you put it out in the wild. And let's move on and see what to do next.